Morning students. Today I am going to discuss regarding to electricity. In this electricity, today's concept is electric current, potential difference, and third thing is I'll discuss regarding to Ohm's law. In next video, I will post regarding to the numerical based upon the Ohm's law and related to electric current and as well as potential difference. So here, first basic thing we will learn regarding to the electricity is conductors. So conductors are the metals which allows the electricity to flow through them. Such a metals are called as conductors. So these conductors are categorized into three types depending upon the free electrons presence in that. So again we have to learn regarding to the what is mean by the free electron. If you will take any metal, every metal is made up of small tiny atoms. So each and every metal having a made up of atoms, the atom having a particular structure. Let us take an example of one of the metal. If you take a copper has a 28 is nothing but electronic configuration, that is number of electrons which are present in that, and 29 number of protons are present. So before going to the bigger number, just we will discuss regarding to a small element, that is with lithium we will start. So if you will take lithium whose number is 3, then in this if you take an atom, in these atoms if you take 3 protons are present, they are positively charged, and 3 electrons are present. These 3 electrons are the 2 electrons in a first orbit, and in the last orbit there is only 1 electron is present. So this 1 electron is loosely bounded with the atom. Then this electron is called as a free electron, which is present in the valence shell. So this electron can able to move from the one atom to another atom easily. The motion of an electron from one atom to another atom is called as electric current. So if you take one more atom of lithium here, then in this also there is 3 protons are present, and 2 electrons are fixed in one shell. In another shell there is one more free electron with me. So this free electron jump from this atom to another atom. Then over the another atom if you consider here, then in this also there is 3 electrons will be, and this outermost electron which is present in the valence shell we will call as a free electron. This free electron is jumped from the one atom to another atom. Then this electron is jumped from this atom to this. So likewise the moving of electron in a conductor is called as electric current. So similar thing takes place in copper also. In copper there is a large number of free electrons will be. Those free electrons are moved from the one atom to another atom. The motion of electron, that is a free electron, we will call as a electric current. So in the year of 19th century, there is a 2 scientists called Lorenz and Drude. They were said in the 19th century, that is conductors like metals like good conductors has a large number of free electrons. These free electrons are loosely bounded in the atom. They can able to move from the one atom to another atom easily, and positive ions are fixed in their location. The arrangement of positive ions in a atom or in a conductor is called as a lattice. So according to Lorenz and Drude, conductors has a metals are good conductors. Metals are good conductors, and they had large number of free electrons. These free electrons easily can move from one atom to another atom. And one more thing they said, positive ions are fixed in their location. So the arrangement of these positive ions, here positive ions are fixed in their location. Arrangement of these positive ions is called lattice. Okay, this is what they said. Metals are good conductors. They have large number of free electrons. These free electrons are helps to conduct electricity in metals. And second thing they said, positive ions are fixed in their location, and the arrangement of these positive ions is called as a lattice. So where there is a positive ions are present, those positions we will call as a lattice. And still what they explained according to Lorenz and Root is, if you take a conductor, conductors are in a cylindrical shape, and these in the conductors electrons are in a random motion. They move in a different direction when there is a potential difference is not connected to them. So these electrons are in a random motion. When there is a potential is not connected across through the any conductor, these electrons move in a different direction. The motion of this electron in different direction we will call as a random motion. So this is how the electrons are moving. Then if you take any cross section area of a conductor, any position if you consider, when there is a battery is not connected, then let us take this A is a cross section area. Then number of electrons are crossing from the left to right is same number is crossing right to left. Means if you take any position of a conductor, then in case of 1 lakh electrons are travel from left to right, similarly 1 lakh electrons are travel from right to left. It means number of electrons crossing through the cross section area, that is net cross section of charges is 0. Net cross section means how many are going from left to right, same are leaving. So net charge is denoted with a Q. Net charge crossing through this cross section area, let me write here, net charge is equal to 0. If net charge is flowing through the 0, then we will say here current is passing through this cross section area is 0. Here because there is no potential difference is connected across the terminals of a conductor. Then in case if you connect a potential difference to this conductor, what happens? Let us see. Let us take a conductor and connect the potential difference across the terminals of a conductor. If there is a potential difference means battery is connected. Then all the electrons move in a ordered motion. When the battery is connected, then these all move in a particular order. So the ordered motion of electrons in a conductor is called as a electric current. So here if you take any cross section area here, then in this cross section area A, net charge is not equal to 0 now. Crossing through the cross section area is not equal to 0. Then we can say that the number of electrons crossing through the cross section area in a time t is called as a electric current. So current it is denoted with I, which is equal to charge crossing through the cross section area per unit time. That is let us denote with the q and a time with the t. Then I is equals to q upon time t. This is nothing but electric current. So definition, you see that charge crossing through the cross section area in a 1 second or in a t interval of a time, then it is called as an electric current I. So electric current is defined as a simple definition is the rate of flow of electrons is called electric current. The rate of flow of electron is called as electric current. This is a simple definition or mechanical definition if you want to say in terms of mechanics. Then Q charges crossing through the cross section area in a t interval of a time, then called as electric current I. So coming to the SI unit of electric current, the SI unit of electric current, from the formula we will define it now. Listen. Already we know current I is equals to charge upon time t over the SI unit is charge is measured in terms of coulomb, time is measured in terms of second, then the coulomb per second is also called as a coulomb second inverse. It is defined as ampere. So while writing complete name as it is a scientist name, then we have to write with a small letter ampere. Symbol is capital A. How to define it? 1 coulomb of charge crosses the cross section area in 1 second is called as 1 ampere. So definition for the ampere is definition is when 1 coulomb of charge crosses a cross section area in a 1 second is called 1 ampere or simply ampere. So this is nothing but a SI unit of electric current. So electric current unit is ampere. Ampere means coulomb per second, or simply say as a coulomb second inverse. Then you can get the doubt here. What is mean by charge? Try to discuss a few words regarding to the electric charge also. So charge is defined as charge is denoted with the letter Q. Charge is defined as the excess or deficiency of electrons is called as a charge. If there is more electrons or less electrons, okay, excess or deficiency of charge, electrons is called charge. So if there is an excess of electrons are there, then it is called a negative charge. Deficiency of electrons means less electrons, more protons, then it is called as positive charge. So charge is nothing but the excess or deficiency of electrons is called as a charge. Excess of electrons means it is a negatively charged. Deficiency of electrons means it is a positively charged. Then charge is measured in terms of coulombs. So SI unit of charge is SI unit is nothing but coulombs. Then how many number of coulombs how many number of electrons makes 1 coulomb? That is we can see here. If there is a 1 coulomb or a minimum charge Q is equals to 1.67 into 10 to the power of minus 19 coulombs together is called as 1 charge, or also can be written as 1 electron. 1 electron is equal to 1.67 into 10 to the power of minus 19 coulombs is called as the 1 electron. Then how many number of electrons together is called as 1 coulomb means, if you do that, 1 coulomb is equals to, send this number to the denominator, so 1 electron upon 1.67 into 10 to the power of minus 19, okay, it will resolve it is 6.25 into 10 to the power of 18 number of electrons. So 1 coulomb is contains 6.25 into 10 to the power of 18 number of electrons. So this is about the briefly regarding the charge, and quantitatively charge is nothing but Q is equals to plus or minus NE, or NQ also sometimes we write, where N is nothing but a positive integer, plus or minus, plus indicate for the positive charge, minus indicate for the negative charge. E is nothing but a minimum quantity of an electron, that is 1.67 to the power of minus 19 coulombs. So this is nothing but quantitatively charge stands for, it is a plus or minus Ne. So here what we discussed is regarding to the two things. What is mean by conductor? Conductor is conductors are nothing but they are metals, and they carries electricity through them. They are called as conductors. Why they are behaves as a conductor means due to the free electrons are present in them. Due to the free electrons, the free electrons travels from one atom to another atom easily. The flow of electrons is called as a electric current. And we discussed regarding to the Lorenz and Drude theory. Lorenz and Drude, two members of the scientists. In the 19th century, they said metals are good conductors and they have a large number of free electrons, and positive ions are fixed in their location. Arrangement of positive ions is called as a lattice. Then they said that if there is a conductor is not connected to the battery or potential difference, these electrons are in random motion. If they are connected to the potential difference, then they are in ordered motion, and they were said the ordered motion of electrons is called as electric current. Okay, and electric current quantitative definition we saw that I is equal to Q by T, where Q is nothing but charge, by T is nothing but a time, and SI unit of electric current is amperes. And definition of ampere we saw that when there is when 1 coulomb of charge crosses the cross-section area in 1 second is called as ampere. Still we discussed regarding to the charge. Charge is nothing but excess or deficiency of electrons in a body is called as the charge. Excess of electrons means negatively charged. Deficiency of electrons means positively charged. And minimum charge of a body is nothing but 1.67 into 10 to the power of minus 19 coulombs. Less than that charge does not exist for a body. So that's why we will call as this is a minimum charge of any body. Minimum charge is present 1.67 into 10 to the power of minus 19 coulombs. Then 1 coulomb is equal to number of electrons. How many number of electrons means 6.25 into 10 to the power of 18 number of electrons together is called as 1 coulomb. And quantitative definition of the charge is nothing but it's a plus or minus integral multiple of electrons is called as the charge. So this is about the electric current and as well as charge. Next we discuss regarding to the potential difference. See, word itself is a potential difference. Potential difference denoted with the V. Let us take a conductor. This is one conductor to which we connect a battery, that is a potential difference. Then let us when the potential difference is connected, then current I is flowing through it is, and let us at a point A and this is a point B and L is the length of a conductor. Here let us say there is a positive charge is present. When the potential difference is connected, according to Lorenz and group theory, these charges will move in a conductor. Then this positive charge starts moving from point A to the point B, because A is having connected to higher potential, let us say B is connected to lower potential. Due to the potential difference, positive charge is moved from point A to the point B through a L length. When a potential difference is connected on this positive charge, there is a Fe is a force is acting, that is electrical force act on a positive charge to move from the point A to the point B. Whenever a force is act on a body moves through a distance, then on that body work is done according to science. So here on a body there is a work is done due to the potential difference. So work done on this positive charge is nothing but Fe is a force is acting Fe, and charge is moving from point A to B to a L length. Then Fe into L length the body is moving. So work done is equals to Fe into L length work is done. So potential difference in this case of motion of positive body, positive charge is defined as work done on the positive charge or work done per unit positive charge is called as a potential difference. So potential difference is defined as a work done per unit charge. So as we know that potential difference of PD, there is a work is done. How much work is done? Fe into L length work is done. On charge, say let us Q charge. On Q charge work is done. Then this Fe is nothing but force, units is Newton. L is nothing but meter. Newton meter stands for joules is the unit, and per coulombs. So SI unit of the potential difference is SI unit of potential difference is Newton meter, or simply work done unit is joules per coulombs, or we can say joule coulomb inverse is called volt, or we can say simply voltage. So it is nothing but volt, 1 volt. SI unit of work, potential difference is nothing but joule coulomb inverse, or it simply can say as a volt, or it is nothing but V represented with a V. So SI unit of potential difference is a volts. Or another name for the potential difference is we can say as a voltage. Voltage is another name for the potential difference. So potential difference is defined as a work done to move a unit positive charge from point A to the point B is called as a potential difference, or it is also called as a old another name. And unit of the potential difference is a work done per charge, that is a W per Q we can say. Already we know W stands for here Fe into L, and charge is nothing but Q, so potential difference is equal to Fe into L upon Q. SI unit is nothing but joule per coulomb or joule coulomb inverse, are also called as volt. The SI unit of the voltage is volts. So this is about the potential difference. Listen, my dear students, till now we discussed regarding to the mainly two concepts. One is current, that is I is equals to charge per time, that is we can say I is equals to Q by T or plus or minus NE upon T also we can write. This is electric current. Second thing we discussed regarding to voltage, or we can also say as it is a potential difference, that is work done per unit charge. So SI unit is nothing but amperes. Here SI unit is nothing but volt, simply denoted with the V. The device which is used to measure the electric current is ammeter. To measure the device electric current is used is ammeter, and this ammeter is represented with the symbol A with the circle, and it is always connected series with the circuit. And to measure the voltage or potential difference, we use a device called voltmeter. Because it is always used to measure the voltage, and it is connected in parallel to the circuit. Why we have to connect this is in series only? The reason is in series for the ammeter has a low resistance with. Okay. Why we have to connect in parallel voltmeter? Because this voltmeter has high resistance in series. So that's the reason high resistance in series will be, that's the reason it is connected in only parallel connection, and it is connected in series connection because of low resistance provided by this ammeter. So this is about the basic thing regarding to the electric current. That is one is what we discussed, electric current and the potential difference. In next video I will post regarding to the Ohm's law and some of the applications related to it in that video. Okay, thank you very much.